What's up mga iis?
The advancement of technology made every human lives easier. In 1882, the world is lit with light bulb, a device which produced light from electricity, and it is widely used globally up until today. As years pass by, inventors develop a device which can lessen human effort, and it is driven by electricity, and that is the electric motors. You might be wondering where electricity came from, and yes, it is from the generator. An electric generator is an electronic appliance that converts mechanical energy into electrical energy. The sources of mechanical energy include steam turbines, gas turbines, wind turbines, and even hand cranks. The simplest elementary generator that can be built is an AC generator. AC generator, also known as alternators, is a machine that converts mechanical energy into electrical energy. The generated electrical energy is in the form of alternating current, sinusoidal output waveform. An elementary AC generator consists of a wire loop placed so that it can be rotated in a stationary magnetic field. This will produce an induced EMF in the loop. A sliding contact or brushes is connected to the loop to an external circuit load in order to pick up the induced EMF. A DC generator is an electrical machine which converts mechanical energy into direct current electricity through the process called commutation. An electrical generator or alternator is a machine which converts mechanical energy into electrical energy by electromagnetic induction. The power for electrical system of a modern vehicle are produced from an alternator. Alternators is categorized according to their design. The first category is the salient pole type. This type of alternator is used as low and medium speed alternator. These are mainly used for low speed turbine such as hydel power plant. The second category of alternator according to their designs are the smooth cylindrical type. This type of alternator is used in steam turbines. The rotor of this generator rotates at a very high speed. Types of electricity generating plants. Nuclear power plants. Using a nuclear fission reaction and uranium as fuel, nuclear power plants generate high amount of electricity. Nuclear power plants emit low greenhouse gas emissions. The energy is considered environmentally friendly. Nuclear power plants require low quantities of fuel but produce enormous amount of power, making them particularly efficient once up and running. Hydroelectric power plants. Hydroelectricity is produced by harnessing the gravitational force of flowing water. Compared to fossil fuels powered energy plants, hydroelectric power plants emit fewer greenhouse gases. Coal-fired power plants. Coal-fired power plants use steam coal as a source to generate electricity and consequently emit a significant amount of harmful gases into the atmosphere. Diesel-fired power plants. With diesel as fuel, this type of power plant is used for a small-scale production of electric power. They are installed for places where there is no easy availability of alternative power sources. Geothermal power plants. The three main types of geothermal power plants includes dry steam power stations, flash steam power station, and binary cycle power station. Combined cycle power plants. Using both gas and steam turbines, combined cycle power plants produce higher amount of electricity from a single fuel source compared to a traditional power plant. Solar power plants. Solar energy plants convert energy from the sun into thermal or electrical energy using one of the cleanest and most abundant renewable energy sources. Solar thermal power plant. Solar thermal is a system of giant mirrors arranged in such a way so that it concentrates the sun rays on a very small area to create significant amount of heat, thus creating the steam to power a turbine that creates electricity. Wind power plants. Wind power plant is used in conjunction with the main grid, which supplies most of the power. The main purpose of the wind turbines is to supplement the energy supply for the grid. Tidal power plants. Tidal energy is generated from converting energy from the force of tides into power, and its production is considered more predictable compared to the wind energy and solar power. Electric motor is the electromechanical machine which converts the electrical energy into mechanical energy. In other words, the device which produces rotational force is known as the motor. The working principle of the electric motor mainly depends on the interaction of the magnetic and electric field. Series type of DC motor. The DC series motor is similar to any other motor because the main function of this motor is to convert electrical energy to mechanical energy. DC series motor is used in vacuum cleaner, traction system, sewing machine, cranes, and air compressors. Shunt type DC motor. A DC shunt motor, also known as a shunt wound DC motor, is a type of self-excited DC motor where the field windings are shunted or connected in parallel to the armature winding of the motor. This type of motor is used in fans, blowers, conveyors, lifts, and weaving machines. Compound type DC motor. Compound type DC motor is a compound of both series and shunt motor. It consists of a series field coil which is connected in series with the armature field winding and a shunt field coil winding which is connected in parallel with armature field winding. Long shunt compound type DC motor. The shunt field winding is connected in parallel with both armature coil winding and the series field winding. While short shunt compound type DC motor, a shunt resistor is only in parallel with the armature field coil. Due to the ability of compound motor to perform better on heavy loads, it is used in elevators, steel rolling mills, printing press machines, and mixers. Alternating current motors. An AC motor is a common type of electric motor driven by an alternating current. AC motor offers a relatively efficient method of producing mechanical energy from a simple electrical input signal. AC motors are frequently used in a diverse catalog of very familiar consumer products and industrial equipment due to their durability, low manufacturing costs, general affordability, and ease of operation. In synchronous AC motors, the speed of the rotor is proportional to the stator. These motors are known for their efficiency in maintaining the power for the overall system and can be used as stepper motors in some cases. Synchronous motors find their majority applications in areas where accuracy is important. For instance, in clocks, timers, electromechanical robots, metering pumps, speed controllers, and other industrial processes. Induction motors are the most common type of AC motors used in daily life processes, and their output rotation speed is proportional to the applied frequency of alternating current. Induction motors are mainly used in water pumps, kitchen appliances, fans and air conditioners, automobiles, and common industrial machinery like boiler pump and compressor. Linear motors produce a linear power to push or pull an object along their length, in place of creating a torque-based rotary action. Due to these properties, linear AC motors are widely used in ground-based rails, monorails, magnetic levitation lines, roller coasters, and similar transportation machinery. Adjustable speed AC motors provide special features in terms of their speed control and management. They are used in systems and processes where automatic switching of rotor speed is required. These specific characteristics gives them applications in marine and land machinery, electrical power plants, cargo pumps, and water cooling equipment. Universal motors are generic AC motors that are operated on both alternating current and direct current sources. The most significant feature of universal AC motors is their constant high rotary speed, which makes them useful in a wide range application like railway traction mechanisms, high power engineering, and commercial drill machines, industrial and kitchen blenders, vacuum cleaners, dryers, and trimmers.